Hi, in this video, we want to take a look at plotting simple feature shapefile maps using ggplot. Okay, so when you're talking about map data, we're talking about boundaries, shorelines, rivers, things like that. The data is going to be stored in different formats. And in another video, I talked about like just regular old polygons. Well, here we want to get into a little bit more technically deep aspect of plotting map data. And this storage format is called simple features. And you'll see this abbreviated SF. Well, fortunately, ggplot, which has a ton of powerful utilities in it, gives us some functions that make it easy peasy to take a simple features data set and convert it into a map very nicely. Now, this example that I'm going to be going over is copy and pasted from ggplot2 Elegant Graphics for Data Analysis by Hadley Wickham. Here is the GitHub page if you want to look at the examples that I pulled from. If you look at the text, Hadley says things like I in there and makes references. Those are references to himself or to his book. I don't deserve the credit here. Hadley is the guy. All right, so simple feature maps, they're basically, for our purpose as a data scientist, really is that they're a format for storing data for maps. That's really it. And we want to be able to take that data type and then drop into a function and generate a nice, beautiful plot for us. Specifically, geom SF is going to be the one that we're really most interested in. All right, so for an example, let's go ahead and grab a SF file. And so here, the OzMaps package has a bunch of Australian maps that we can use very nicely. And so here, we're getting the states of Australia. And this is stored in an SF data format. All right, well, if I go ahead and take a look at it, we can see that we have 9 features. It's stored in a multi-polygon format. Dimensions are XY. And here is the latitude and longitude box that we'll use to limit the plotting area. Now, something that's nice about this SF format is that when I pull this up, I immediately can see what I have for my data. In other formats for map data, it's not always clear what I'm working with until I start like doing some data manipulation. Right off the bat, we can see that we have geometry and we have name for all 9 of the geographic regions. Now, the one that's most important is geometry. This actually defines what are the boundaries of what's going on. So here, this is going to be a point along the boundary. This is going to be another point along the boundary, and so on. And that boundary corresponds to New South Wales. Now, it is possible for us to have other columns of metadata. Here, name is the metadata that we're interested for this example. All right, so something that's very easy for us to pull out very nicely is that's 9 distinct geographical units. And we know that because it's a 9-row tibble. Now here, if you remember from the previous video where I looked at polygons maps with ggplot, it wasn't nearly as clear when I looked at the Florida counties data sets. So the geometry part is the part that's the most important to us because that's where we get our boundaries from. All right, so I'm going to use ggplot. So I go ahead and get that loaded in my workspace. And I use the standard ggplot function. And I put in the SF data set in there for the data. Now, geom SF will actually go and it will figure out that this is an SF data set. It'll figure out how to extract the data, and then it'll go ahead and plot it. Now, if I don't put coordinates, SF what's going to happen is it's going to stretch the latitude and longitude directions to maximize the plot in relation to the plotting area. Now, this will distort my impression of the map. So I don't want to do that. So include chord SF in there. And when I do that, we see a beautiful picture of Australia. All right, so there's 3 ways that geom_SF goes about grabbing the actual coordinates. And so the user does nothing. It's going, geom_SF is going to attempt to map everything using the geometry column. Now here it's possible for geom_SF to detect the geometry, even if it's not called geometry. So first go, it tries to find geometry. Second go, it tries to find the geometry column, even if it's called something else. Now, there could be ambiguity in this. It could get mixed up. So it's better to call it formally. And another thing that we could do, we could actually specify using the mapping portion of ggplot using AES. We can say geometry equals the particular name inside the SF dataset. And the coordinates SF makes sure that we have the right ratio and the right projection going on to make sure that everything looks good. Now, layered maps. All right, so one of the reasons why we like ggplot so much is that what I can do is I can actually layer different data points I have onto the same plot. And so this way I can, I can tailor my plot to get the best map, the best informative map possible for the situation I'm going through. Now, if you look at the example from Hadley's textbook, he goes through and he does a filtering on other territories for this upcoming example. I could not get that to work on my machine, so I just skipped that step altogether. All right, so what we're going to do, we're going to create 2 layers. What we're going to do, we're going to go with the Australian maps, states data sets, and we're going to go through and we're going to use the Australian maps package and get the voting boundaries. And so here I'm using ABS, so that's Australian Bureau of Statistics, CED, for the voting boundaries from the AusMap package. And then I'm going to reshape it using our map shaper in the format that will work for ggplot. And so now here, we're going to have 1 layer in ggplot that uses the states boundaries, and we'll have another one for voting boundaries. Let's see what happens. And so now I have a very nice impression of the voting boundaries. Now, when you look at this, what happened is that ggplot first plots whatever's highest up gets plotted first. So what it did, it went through and it drew this map. And you'll notice that there's no boundaries within the states. Down here, after that map was drawn, well, one thing it did also, it colored each state, and then on top of the colored states, it took this data set and then applied boundary lines, which we can see very nicely here. Now, something that's very nice about using geom_SF is that we can go in and we can add labels and text, just like with regular geom label, geom text. So geom label, I put on some text, and I put a box around it. If I use geom text, I'm just putting the text I want and just basically printing it. There's no boundary around it. Now, the difference here for the SF data sets is I just put SF between the geom and the specified function. All right, so then let's go ahead and let's get a data set to work with. Let's go ahead and let's plot like areas within Sydney, Australia. All right, so I'm going to go with OzMaps again. I'm going to grab the Australian Bureau of Statistics CED data set. And now what I'm going to do, I'm only going to grab the regions that are inside this set. And now I'm not familiar with Australia. I'm not familiar with Sydney. I'm just copy and pasting. I believe that these are regions of Sydney, specifically electoral regions of Sydney. And so now what I'm going to do, I'm going to plot the Sydney map using geom SF. I'm going to fill in by the name. I'm dropping the legend. Now here, coordinate SF, I was able to control the latitude and longitude to get a closer zoomed up image. Now, if you look at the actual documentation that's from Hadley's book, it actually zoomed in more closely. If you specify like a smaller range of numbers, it'll zoom in and you'll lose the outer edge of your map. I zoomed it back so we get the entire map rather nicely. Now here, I just put on the label of each electoral district. And so we can see each electoral region of Sydney, Australia. And something I like about geom SF is that it gives us, instead of positive, negative numbers, it actually specifies north, south, east, west. Now, something else that we can do is that we can add on other data and put that on top of our map. That way we can pull out more information. So to do that for this example, I need a data set that has the capitals of Sydney, or excuse me, the capitals of Australia. And this data set has the city and then the coordinates of each of the capitals. Then once again, I'm calling ggplot. Now notice I don't have a data set inside my ggplot call. That's because each layer, each geom is going to have a different data set. So for geom SF, this is drawing boundary lines. I've got the voting districts. For the states, I'm drawing the boundary lines. Now for geom point, what I'm doing, I'm taking this data set up here, and now I'm going to put a dot every time that we have a capital. I'm going to make it a red dot in particular. And you'll notice I have to specify my data and my mapping each time inside the geom functions. And boom, we have a nice map. So now looking at this, when I look at states and I look at electoral boundaries, we can see that it's not really clear which electoral regions go within each state. Something I might want to reconsider doing is rerunning this, but without the voting boundaries. All right, well, that's all I've got for you. Take care and goodbye.